Hello everyone, welcome to the 7th International Virtual Workshop on UA Green Metric World University Rankings 2021. The topic of my presentation is estimation of rainwater harvesting potential in an educational institute of Faisalabad, Pakistan. Myself is Syed Husnain and I am lecturer in Department of Civil Engineering, the University of Faisalabad, Punjab, Pakistan. These are the contents of my presentation: introduction, objective, methodology, results, conclusions and recommendations. So I will start with the introduction. Fresh water is one of the fundamental right of humans. Groundwater is the largest source of water being used in the world. And urbanization and overpopulation are leading to the depletion of groundwater reserve. It is expected that serious issues relevant to groundwater reserves will occur by 2025 if remedial actions will not be taken by applying new policies for water conservation. And my country, Pakistan, is at 5th among the populated countries in the world, with a population of over 225 million, and our main source of water is the groundwater, which is being used at household or in industry and etc. Also, if I talk about the city of Faisalabad, it is a major industrial city of Pakistan with an approximate population of 3.2 million, and the city is completely depend on groundwater. With increase in population and urbanization, the exploitation of groundwater by pumping is getting higher, and the water table of the city is declining at an alarming rate. Also, water conservation is now a need of the time for the better water management and sustainable environment for the humans to live. So due to over exploitation, water reserves are getting down. So for our future generation and sustainable development, we should save some water by applying rainwater harvesting technique, in which we can collect water and we can store it and we can use it in future. So the aim of the study is to estimate the rainfall runoff volume that can be conserved by using rainwater harvesting technique in the University of Faisalabad Amin Campus, which is located in the province of Punjab, Pakistan. The main objective is to propose a system of water conservation in the University of Faisalabad to encourage the sustainability practices. As we can see in the map, that it is located over here in Punjab, the study area. And if I talk about the coordinates, latitude and longitudes, these are the latitude and longitude of the location where this study is being done. And the total area of the Amin campus of the University of Faisalabad is 16,160 square meters, and we have considered rooftop areas of the buildings in this study, and measurements are taken by conducting engineering survey in the campus. So these are the these are the areas of the rooftop of different buildings, and here we can see the plan of the study area. Here it is OPD block, and this is the main building. This is electric room, bank, labs and cafeteria, and areas in square meter are also mentioned over here. And also if we sum all these areas, the total is 4,207.6 square meters. Okay, if I talk about the water consumption, The source of water here in the campus is the groundwater, and there is water tanks installed in the main building and OPD block. One 6 cubic meters capacity water storage tank is installed in the main building, and three 1 cubic meters capacity water storage tanks are installed in the OPD block. So observations are done for a year, and it was observed that 653 times the filling of the main building's tank was done 653 times per annum, and the tanks present in the OPD block are filled 365 times in a year. So water consumption is around 5013 cubic meters per annum. Rainfall data for the study is collected from the Pakistan Meteorological Department from January 1981 to June 2021. For the city of Faisalabad, monthly average rainfall is calculated, and also rainfall depths and runoff depths are calculated. So if I talk about the average monthly rainfall for the city of Faisalabad, it is shown in this figure, and we can see that the maximum average rainfall is in the month of July from the 1981 to 2021. For the calculation of the runoff, Soil Conservation Service curve number method is used, which was developed by National Resources Conservation Services (NRCS), and this equation 1 is used for the effective runoff depth, and here P is the rainfall event depth, S is the potential maximum retention, and Cn is the curve number. So the higher the curve number, the less will be the losses. Also in equation 1, if the factor 0.2s, which is initial abstraction, if it is greater than the event value P, then the effective run of PE is taken as 0, because the initial abstraction is, if initial abstraction is greater than the total rainfall, then definitely the obviously the effective runoff will be 0. Also for our area, as it is rooftop area and it has good hydrological conditions, as curve numbers depend upon the soil group, hydrological conditions, land cover, and NTDs and moisture condition. So the laws which are defined by the NRCS in this rule are adopted, and the curve number of 98 is selected for our study area, and the potential maximum retention is calculated by using the equation 2, in which we have entered the value of curve number, and we have calculated 5.18 millimeters the initial abstraction. So runoff volume was calculated by using the effective rainfall depth, and we divided it by 1000 in order to convert it into the meters, and we multiplied it with the total measured rooftop area, and we have our volume in meter cubes. Then we multiply this volume by 0.95 in order to have the final volume that can that we can conserve, because 5% conveying losses are assumed in the calculation. So the results are, the total calculated rooftop area is 4207.6 meters square, and the calculated curve number is 98, and potential maximum retention is 5.18 millimeters. And if I talk about the rainfall depth, average rainfall depth from 1981 to 2021, it is 399.87 millimeters. And if I talk about the runoff depth, it is 325.4 millimeters per annum. And also the rainfall runoff volume is calculated as 1369.2 cubic meters, and if we deduct 5% conveying losses, it will become 1300.74 cubic meters, and it is 25% of the total water consumption of the campus. And this figure shows the rainfall and runoff relation, and we can see that there is not much difference in the peaks of the values of the runoff and rainfall, and therefore the runoff coefficient is high for this study. And also this is the proposed rainwater harvesting system. We can see in this figure that we are going to use the already installed drainage pipes that are delivering water from the rooftop to the bottom, and this water was drained into the drainage pipes previously. And if we had installed these horizontal or underground pipes and convey water by gravity flow to this designed proposed storage tank, which will be installed at the playground in the university, then this huge amount of water can be saved and preserved for the use. This is another view of the 3D diagram. We can see that these are the conveying pipes which will be installed underground, and gravity flow will be allowed, and we can transfer water, convey water through these pipes to the storage tank. So the conclusion of the presentation is that we can conserve about 1300 cubic meters water per year if we install the rainwater harvesting, which is a harvesting system, which is 25% of the water usage per annum in the university. And also the runoff coefficient for the campus is around 0.81, which is 81% of the total rainfall that is observed. And economic analysis is recommended for the rainwater harvesting system if it needs to be applied, and it is recommended that economic analysis should be done in order to have a optimum design. So at the end I will ask all the audience to please save water for the future, and thank you very much.